Hello guys, welcome to another video of Introduction to Python or Beginner Python. Um, so in this video, we are going to be talking about um, data structures, and in specific, we will be covering what we call as lists, right? So first of all, for those of you who are new to programming, let us let's briefly describe what a data structure actually means. It's very simple. A data structure is anything that can store group of data or set of values, whatever we would like to call it. So we saw that a variable can only store one particular value. So we can say a is equal to 1 or name is equal to Vishal, something like this. And the types can be of integer or float or string or whatever. But a data structure can store a combination of data types. So for example, if you take a list, that'll take a form of you have a square bracket, and within a couple of square brackets you can store a set of numbers like 1, 2, 3, 4, right? Or you can do anything. You can store um, a bunch of strings like hi, hello, whatever, right? So that's the main difference between a variable and a data structure, right? So what happens is we know now that a data structure can store a set of values. So what are the different types of data structures then? So we have a list. We have something called a tuple. This is in Python, to be specific. In Python, different programming languages have different data structures. This is specific to Python. You have a tuple. So a tuple is indicated by a parenthesis. So you would store a bunch of value inside the parenthesis. You have a dictionary. Where you have some flower brackets and you store some data inside flower brackets, which we will talk about later on. Something like this. We'll look into that a bit later on. You have a set. So a set is where, again, you have curly brackets, but it can only store unique values without any duplicates, right? So these are the inbuilt Python data structures. Now, there are some libraries that offer enhanced versions of data structures, like you have a NumPy array, or you have a pandas series, or a data frame, which we will be looking into later on, right? But in this particular video, we will focus purely on lists, right? We're going to focus purely on lists. So I hope it's clear what a data structure means. So let's have an introduction to what a list is. So Well, I think a better way to start would be to discuss the properties of lists, because we know what a data structure is. Let us discuss the specific properties of a list. What makes it unique? What makes it different from other data structures? So, the first and foremost thing is a list is an indexed data structure. It is indexed. So, what do you mean by an index? So, we know that a list can store multiple values 3, 5, 8, 9, something like this within square brackets. When I say indexed, I mean that each of these elements within the list carry a reference. They carry a reference, and that reference is called an index. So the index starts with 0. So the first element within the list will have an index of 0. Similarly, the second one will have an index of 1. The third one will have an index of 2. Fourth one will have an index of 3, and so on. So this is called the index, right? So usually in the real world, we start with 1, 2, 3. In the programming world, we always start with 0. We say the 0th element is always going to refer to the topmost element or the first element within my list. And then I'm going to go to my first. So I always start with 0, right? So that's the first property of a list. The second property is that a list is heterogeneous. List is heterogeneous. So what do I mean by heterogeneous? It means that it can store multiple kinds of data or multiple types of data. So I can start with an integer type, then I can follow that by a string type, then I can have a float type. It's totally fine. I can have different kinds of data or different types of data within my string. Absolutely fine. So that is what we mean by heterogeneous. It can store different types of data. A single list can have different types of data. The third one is a list can include duplicates. So duplicates are allowed. So I can have a list like this, 3, 3, 3, 3, 3 with 5 threes. It's totally fine. Absolutely no problems. Right? And the fourth property, which is a very, very important property, especially when you're attending interviews, is that a list is a mutable data structure. It's a mutable data structure. So what do you mean by mutable? It means the elements can be replaced. The elements can be replaced. So for example, if I start with a list with 3, 7, 9, 8, I can always modify this. Let's say I want to modify the 0th element. I can modify the 0th element within the same list L, and I can make this, I can replace 3 by anything I want. Like maybe let us say I will want to replace 3 by high. I will replace 3 by high. And it's the same list. It's not even a new list. It's the exact same list. So, That's the fourth property. The fifth property is a list can contain a list. A list can contain a list within itself. So what do I mean by that? It means if I have a list L, within this list, I can have other lists. 1, 2, 3. This is one list. 3, 4, 5. This is another list. And then maybe I can follow that up with a single integer type element. So it's totally fine. This portion, these lists are called nested lists. This is nested list 1. This is nested list 2. And this is just an element. Right? So these are the main properties of lists. There are many other micro properties which we are going to see. But yeah, so it's indexed, heterogeneous, it can have duplicate values, it's mutable, which means you can pick any value you want and you can change it. And a list can contain other lists within it or a nested list within it. Right? So these are the major properties of lists. So now let's get our hands dirty and start some coding. So we saw how we can define a list. So we can just say L is equal to, I will start with square brackets and I have a bunch of values, 7, right? So it's as simple as that. And we know that a list can have any kind of data, right? So I have 2, which is int, 3.14, which is float, and then I can have my name, Vishal. All right, so that's, you have L, L1, L2, whatever you want. So lists can be heterogeneous or they can be homogeneous, right? And we also discussed the mutability of lists, which is a super important aspect of lists. So let me take list L. My list L looks like this. So let us say I want to replace 1 with something else. How would I do it? I would access 1. How do I access 1? How do I access this element? Well, 1 is my 0th element. So I can access my 0th element. See, and I can access my 1th element. And I can access my 2th element. I can access my 3th element. Or 3rd element, whatever you'd like to call it. So when I say a list is mutable, what I mean is I can just say L with 0 inside my square brackets, which means I'm accessing my 0th element. And I can just say replace that with hi. It's totally possible. No problems at all. So now if I see my list, you can see that the first element is replaced with a hi. Similarly, I can do that to whichever element I want. I can access the 4th index, which is 5 in this case, and I can replace that with 3.14. Again, very much possible without causing any issues, as you can see. So that's the mutability of lists, right? And then we also saw that we have nested lists. So that is a list having multiple lists within itself. So I can say 1, 2, 3. Hi. Hey. Hello. And maybe 4.554, 7.54, and 2.1. Right? So you have 3 lists within one list. Simple as that. 3 lists within one list. So now, is indexing still possible? Yes, it is. You can just say L of 0, you will get the first list. L of 1, you will get the second list. L of 2, you will get the third list. L of 3 will give me an error because L of 3 does not exist. It's only 0, 1, 2, right? So you can access the nested lists. Now, what if I want to access an element within the nested list? Again, it's very much possible. So L of 0 will refer to the first list within my L. Now let us say I want to access the 1th element or the element with index 1. Within my inner list, I can just say 1. This will help me access the element within a list or within a nested list. So similarly, I can select the first or the 1th list from my main list. And maybe I can access the first element within that list. That'll give me high. Right? So how would I access the first element within my third inner list? So that'll be first I should access my third list, which is my 2th list, L of 2, and my first element within that will be 0, the 0th element. So that'll give me that. Right, so this is how you would access elements within an inner list. Right, very simple. Now, another fun property of lists, or rather than a property, some kind of an operation you can perform on lists, is called slicing. It's called slicing. So what does slicing mean? So you have a list. Let me copy this list. For simplicity, I will take a simple list. And let me extend this a bit to 9. So slicing means I can select a starting index and an ending index, and I can only get a selected number of elements as the output. So what do I mean by that? I'll say L. Okay, then I'm gonna access my elements. So I'm gonna start with 0. I'm gonna follow that up with a colon, and I'll say I want to go until my 5th index. If I say enter, you can see the first 5 elements within my list, or index 0 to index 4. This index, the second index or the last index that you provide, in this case, the second index within the square brackets is ignored. So the 5th index or the 5th index, 0, 1, 2, 3, 4, 5. This one is not printed or is not outputted. Only excluding the 5th, you will get the output. So 0, 1, 2, 3, 4. That's all you'll get. You're not gonna get the sixth element, right? Similarly, it is very much allowed to, maybe I want to start from a different index. Let me start from index 3 and go to index 7. Again, very much possible. So 0, 1, 2, 3, starting from the third index and going all the way to 4, 5, 6, sixth index. And of course, I'm going to exclude 7 because the last one is not included, it's excluded. So this is, the basic slicing step. You're also allowed to select a step size. So what do I mean by a step size? Let us say I want the first 5 elements, but I want to skip 1. I want to skip by 1. So I'll say 0 to 5, 2. And if I say enter, the step size is 2. The step size is 2, which means I'm jumping not by 1, but by 2. So to be more clear, let me showcase to you by drawing. You start with 0, 1, and 2. You come to 3. Again 1 and 2. You come to 5. So you're taking a step size of 2. 1, 2, 1, 2. So that is what this particular number or position indicates. It's a step size, right? So similarly, I can extend that and I can do various kinds of operations using the slicing concept. I can say, give me elements from 3 to 8, skip by 3, which is totally doable, right? So this will start from index 3, go till index 7, and it'll skip by 3 steps. So that is about basics of slicing. If you want to reverse a list, So let's see how to reverse a list. What you're going to do is you're going to do something like L colon colon minus 1. So this is going to reverse my list. Now what is minus 1 here? So whenever you see a negative number, it means you're starting, or rather it refers to the ending of the list. So if I say L of minus 1, that's gonna give me the last element of the list. Similarly, L of minus 2 is going to give me the second last element of the list. Now if I do minus 5 to minus 2, now that will still give me the minus 5th one, 0 or 1, 2, 3, 4, 5, and it'll minus 4, minus 3, and minus 2 is not going to be included, right? So let me explain that. So if you do something like minus 5 to minus 2, it means it's going to go to minus 5. This is minus 1, minus 2, minus 3, minus 4, minus 5. This is minus 5. It's going to start here. It'll go to minus 4. It'll include -5, -4, -3, but it's not going to include -2 because this is not included, right? So that is exactly what we saw. We saw 5, 6, and 7 in our output. So you can access it through negative numbers as well, but be a little cautious because you cannot do something like L of -10 because there are only so many elements. There are only 9 elements, right? So you cannot do -10. You can only do -9, which will take you to the first element. You can also do something like 8 and 1. That'll give you an empty list. So this is sort of, you can say, invalid. Not invalid, it'll just give you an empty list. Because you're sort of starting from 8 going to 1 doesn't make that much sense. So it'll give you an empty list, right? So if you do rather 8, 1, and let's say something like -2, in this case, it'll be a little different. It's going to start from the 8th index, go all the way to the first index, excluding the first index, taking -2 steps. So it's going to start with the 8th index, which is 9. It's going to go all the way to the first index. It's going to take -2 steps. So it's -1, -2, give you 7. -1, -2, it'll give you 5. -1, -2, it'll give you 3. But it'll not give you 1 because, that's not included. So majorly, these are the different slicing techniques. So if you do something like this, that'll just give you the entire list. So if you leave any of this, any side, either side of the colon blank, it means you want to start with 0 and you want to go until the end, go until 10. That's what it means. So when you leave anything blank, it means you want to access the maximum or the minimum value. So if I do this, it means I want to start with the minimum value. It's going to start from the 0th index. If I leave this empty and if I put 4 here, it means I want to go till the maximum value. Start with the 4th index, but I want to go till the end. So that's what happens if you just leave it blank, right? So I think those are the major cases. If you want to reverse skip the elements, so you can say again, to reverse, you just leave you just put 2 colons in. Putting -1 is going to reverse it, but if you want to skip by 2, while you reverse, you can do something like this, right? So you reverse and you skip by 2 as well. So these are some of the edge cases as well. So this is about list slicing. We will take a look at some major list-based functions. There aren't, I wouldn't say it is as important as a lot of other things. However, it's something that you would say is good to know. So let's start with some few simple ones. So I can say, so first let me say major list functions. So nice, it's good for utility, I would say, right? Good for utility, not too commonly asked, at least in my experience. So you can say length of your list and you can say len of L. This will give you the length of your list. So I think that's pretty straightforward. So this will give you length. Right, and you can do something like sorted list. This will, it's already giving you a sorted one, so that's not an issue. You can do count, or you can say list.count rather, l.count, which will, it's going to say l.count and you got to put in the number. So if I want to count the number of twos, there's only 1 2 within my list. If I want to see the number of fours, there's only 1 4. So it'll give me 1 again. So if I change that up a bit, I can say 9 4. Then add these two. Now if I do that, you can see it'll count the number of fours, which is 4 2. I can do this, it'll give me 0. There is no 10 in my list, right? So these are some basic list-based functions. Now if I do l.sort, it will sort the elements in my list, which is exactly what we saw here. But this is not going to modify my original list. This is not going to modify my original list. So to give you a better indication of that, let's take this list here. So if I do sorted of L, you can see it's going to sort my list, but the list itself is unchanged. Let me print list again. See, the list itself is unchanged. It just outputted the sorted version of the list. So this outputs the sorted version of the list, but it's not, list itself is not sorted. However, if I do l.sort, my list itself gets sorted. So now you can see my list itself is sorted, sorts the original list itself, right? So you can say reverse is equal to true. So I think you can guess what it does. It's just going to put it in the descending order, right? You can do sum of list, which will give you the sum. You can do the min of list, which will give you the minimum. Or you can also append or add a value to a list. So I want to add 23 to my list. It's going to work totally fine. So if I see my list now, you see 23 is added to the end of it. So these are some major functions of lists, right? Major list-based functions. Pretty straightforward, nothing too complicated. Now, what if, what will happen if I take, let's say I take L1 is equal to 3, 4, 5, 6. Let's say L2 is equal to 5.67, 7.89, 4.21. I have two lists. What if I, let's say, what if I do L1 plus L2? What am I gonna get? Do you want to guys take a guess for a moment? Well, what that's gonna do is that's going to combine the elements of the lists. It's not going to add the elements to each other. It'll just append elements of list 2 into list 1. Append elements of list 2 into list 1. Similarly, I can do this to any number of lists I want. So I can say take L3 is equal to 5 comma 6, right? And I can say give me L1 plus L2 plus L3. So it's gonna append all elements of L2 into L1 and L3 into L1 plus L2. So that's another nice little thing that can be done. So does that mean I can do L1 divided by L2 as well? No, I can't. So that's not allowed. So does that mean I can do L1 minus L2? Again, that's not allowed. It can only use the plus sign, not to add elements, but to rather combine the elements of lists or append the elements of lists into the other. So that's the main use case of that. So I think those are the major list-based functions. One last thing, there is something called a range function. Let's say you want to store values from 0 to 100 within a list. I'll have to start from 0 all the way to 100. I don't want to do that, right? So there's a function called range, and I can just say, give me values all the way from 0 to 100 like this. So now this list will have the values all the way from 0 to 100, right? So I can access all the elements. When I try to print it, it's going to say some range-based function. But if I want to get the exact list, I can do something like this. List of L will give me that particular list. So that's about lists. Pretty straightforward, very easy concept. So yeah, in the next session, we'll talk about some other data types or data structures rather. Thank you. See you in the next session.